It just so happened to be the day the lovely Miss Johnson decided to explain the class's favorite unit, limits and derivatives, when the handsome and flawless Clayton Bishop decided to play Temple Run.
Push it to the limit. Walk along the razor's edge, but don't look down, just keep your head or you'll finish.
Clayton felt confident he knew the unit, so he left for Mammoth that weekend prepared to use his knowledge of limits and derivatives while snowboarding.
Past the point of no return, reach the top.
The slope looks gnarly. I should try to calculate it before dropping in.
So if this is my current position, 20 feet above the ground, and 0, 0 is the jump which I want to hit, I know an equation that can give me the slope of this line as I approach 0.
Awesome! They already gave me the equation of the mountain. Now I can calculate the slope.
Now I think I can use limits and derivatives to find the slope here, but I was a little bit busy playing Temple Run while Miss Johnson was teaching about this, so I'll do my best. So because I know the equation of this mountain is x squared plus x, and I know that x at this point is 20, I can use derivatives to calculate the slope. So by using my trusty derivative formula, f of x plus h minus f of x over h, I was able to calculate this. I took my limit as h approaches 0 and plugged in x plus h for all of x's. I then simplified right there to go to cancel my h's and then come up with this formula, which I then simplified to 2x plus 1. Take it away. So this was my calculated m value, which is also slope. Once I found the equation for m, I was then able to plug it into the formula y equals mx plus b. So then I plugged in my 2x plus 1, which I calculated for m, into that equation. So I got 2x plus 1 times x plus b. I then plugged in x up here, because x equals 20. So then I plugged in 20 for x, and I got the slope is 840. So now I have my final equation for the slope of this mountain, which is 840. Alright, time to go shred.
I think I calculated the slope wrong. This doesn't feel right.
Because of his injury, Clayton stayed home from school for a week while meeting with the doctors to get his arms and nose checked out. In his downtime, he tries to run through the math he did right before he went to hit the jump. He hit his head pretty hard, so he didn't remember all of his work, but he knew something was wrong. Too bad he was busy playing Temple Run in class. The week after that, he went back to school and talked to Miss Johnson.
I'm sorry I was playing Temple Run in class, but now I don't know what you said, and I was wondering if you could teach it to me so I can go shred the mountain.
You know, I'm disappointed, Clayton. You should not be playing Temple Run in class. But you can ask Ross or Emmy. They're both very good at the material, and they can probably help you.
Okay, thank you. I don't know what I did wrong. It all seemed so perfect.
Okay, yeah, I know what you did wrong, so let's go inside and I'll show you what you did wrong.
Cool.
Okay, Clayton, so you did everything right. You got everything set up right. You have the f of x and the f of x plus h. You got the equation set up right, like so. You distributed everything properly. You crossed out what was needed and got rid of the h as well. And then you plugged in what's 0 for h, and then you were able to get the f prime of x equals 2x plus 1. That's good, but there's just one problem.
So this is where you went wrong. You plugged your derivative into the slope. So what you should have done is plugged your x value into the x for the derivative. You should have gotten 41 instead of 840.
Oh, that makes so much sense.
Now that I know the slope isn't as high as I thought it was, I can drop in safely and hit the jump with enough speed. Let's do this. Oh, my speed feels so much better now that I know my slope.